An airborne early warning and control system is an airborne radar system designed to detect aircraft, ships, vehicles, missiles, and other incoming projectiles at long ranges and perform command and control of the battle space in an air engagement by directing fighter and attack aircraft strikes. These units are also used to carry out surveillance, including over ground targets, and frequently perform battle management command and control. When used at altitude, the radar on the aircraft allows the operators to detect and track targets and distinguish between friendly and hostile aircraft much farther away than a similar ground-based radar. Like a ground-based radar, it can be detected by opposing forces, but because of its mobility and extended sensor range, it is much less vulnerable to counterattacks. This aircraft are used for both defensive and offensive air operations, in addition to being a highly mobile and powerful radar platform. The system is used offensively to direct fighters to their target locations, and defensively, directing counterattacks on enemy forces, both air and ground. So useful is the advantage of command and control aircraft operating at a high altitude, that some navies operate such aircraft from their warships at sea. AWACS, Airborne Warning and Control System, is the name of the specific system installed in the E-3 and Japanese Boeing E-767 AEW&C airframes, but is often used as a general synonym for AEW&C. The E-3 Sentry is a modified Boeing 707 commercial airframe with a rotating radar dome. The dome is 30 feet in diameter, 6 feet thick, and is held 11 feet above the fuselage by 2 struts. It contains a radar subsystem that permits surveillance from the Earth's surface up into the stratosphere, over land or water. The radar has a range of more than 250 miles. The radar combined with an identification friend or foe, or IFF, subsystem can look down to detect, identify, and track enemy and friendly low-flying aircraft by eliminating ground clutter returns that confuse other radar systems. Major subsystems in the E-3 are avionics, navigation, communications, sensors, radar and passive detection, and identification tools. The mission suite includes consoles that display computer-processed data in graphic and tabular format on video screens. Mission crew members perform surveillance, identification, weapons control, battle management, and communications functions. The radar and computer subsystems on the E-3 Sentry can gather and present broad and detailed battlefield information. This includes position and tracking information on enemy aircraft and ships, and location and status of friendly aircraft and naval vessels. The information can be sent to major command and control centers in rear areas or aboard ships. In support of air-to-ground operations, the Sentry can provide direct information needed for interdiction, reconnaissance, airlift, and close air support for friendly ground forces. It can also provide information for commanders of air operations to gain and maintain control of the air battle. As an air defense system, E-3s can detect, identify, and track airborne enemy forces far from the boundaries of the United States or NATO countries. It can direct fighter interceptor aircraft to these enemy targets. Experience has proven that the E-3 Sentry can respond quickly and effectively to a crisis and support worldwide military deployment operations. AWACS may be employed alone or horizontally integrated in combination with other C2BM and intelligence, surveillance, and reconnaissance elements of the theater air control system. It supports decentralized execution of the Air Tasking Order Air Combat Order. The system provides the ability to find, fix, track, and target airborne or maritime threats and to detect, locate, and ID emitters. It has the ability to detect threats and control assets below and beyond the coverage of ground-based command and control or C2, and can exchange data with other C2 systems and shooters via data links. With its mobility as an airborne warning and control system, the Sentry has a greater chance of surviving in warfare than a fixed, ground-based radar system. Among other things, the Sentry's flight path can quickly be changed according to mission and survival requirements. The E-3 can fly a mission profile approximately 8 hours without refueling. Its range and on-station time can be increased through in-flight refueling and the use of an on-board crew rest area. After having developed chain home the first ground-based early warning radar detection system in the 1930s, the British developed a radar set that could be carried on an aircraft for what they termed air-controlled interception. The intention was to cover the northwest approaches where German long-range Focke-Wulf Fo-200 Condor aircraft were threatening shipping. Aventur's Wellington bomber was fitted with a rotating antenna array. It was tested for use against aerial targets and then for possible use against German E-boats. Another radar-equipped Wellington with a different installation was used to direct Bristol Bullfighters toward Heinkel E-111s, which were air-launching V-1 flying bombs. In February 1944, U.S. Navy ordered the development of a radar system that could be carried aloft in an aircraft under Project Cadillac. A prototype system was built and flown in August on a modified TBM Avenger torpedo bomber. Tests were successful, with the system being able to detect low flying formations at a range greater than 100 miles. It was also recognized that a larger land-based aircraft would be attractive. Thus, under the Cadillac Guide program, multiple Boeing B-17G Flying Fortress bombers were also outfitted with the same radar. The Lockheed OEV-NEC 121 Morningstar, which first flew in 1949, served widely with U.S. Air Force and U.S. Navy. It provided the main AEW coverage for U.S. forces during the Vietnam War. Developed roughly in parallel, and class blimps were also used as AEW aircraft. Filling gaps in radar coverage for the continental U.S., their tremendous endurance of over 200 hours being a major asset in an AEW aircraft. In 1958, the Soviet Tupolev Design Bureau was ordered to design an AEW aircraft. After determining that the projected radar instrumentation wouldn't fit in a Tupolev 95 or a Tupolev 116, the decision was made to use the more capacious Tupolev 114 instead. During the Cold War, United Kingdom deployed a substantial AEW capability, initially with American Douglas AD-4W Skyraiders, designated Skyraider AU-1, which in turn were replaced by the Fairey Gannet AEW-3, using the same NAPS-20 radar.